Now, uh, am I audible, students? Online students, am I audible?
Yes, sir.
Now I'm audible,
Yes,
is it
sir.
not? Yes.
Yes, sir.
So now there are two things which has to be understood. One is pin effectiveness and pin efficiency. Both of the things we will see. So one is called, so we will go with pin performance. Pin performance is measured in two ways. Performance, no performance. Okay, it's measured in two ways. One is pin effectiveness, which is given as epsilon f, which is given as heat transfer with the fin divided by heat transfer without fin. Heat transfer with fin. What do you want? Pen? Oh, you want your seat? ಕುರ್ಚಿಯ ಆಟ ಇಲ್ಲಿ ಬನ್ನಿ ಅಲ್ಲ. I'm giving you a seat in the front. Yeah. There, the problem, the thing is that you get that. It's okay. No, no, you get to sleep. If you want, you can sleep like this. So, fin effectiveness, okay. Heat transfer with the fin and heat transfer without fin ratio. Effectiveness of the fin can be written as Q of the fin divided by H A cross section divided by theta B. Correct? Heat transfer without fin is HAC theta B. Heat transfer is Q of the fin. Makes sense? Q dot. I have put Q dot everywhere. So Q dot. Makes sense? Hope you get the point. Very, very important, students. Next. Another one which is there here is, see, for a infinite fin, for a long fin, for a infinitely long fin, for an infinitely long fin, epsilon f, that is fin effectiveness, is equal to square root of HA, HPKA, HPKAC into theta B divided by HA theta B, which gives as square root of HP divided by, sorry, KP, I'm very sorry, KP divided by HT, KP divided by HAC. That is the fin. Makes sense. Simple things you have to apply, then you'll get. So this is important. This is important. Okay. What's the number we have gone till here? 15, 16. Then you go with 17 and maybe ineffectiveness for long fin. Okay. Epsilon long fin. This is 18. Fine. And for to say insulated fin, fin tip, insulated tip This is equal to square root of HPKAC into theta B tan HML divided by HAC theta B, which gives us KP divided by HAC square root into tan HML. Put this as equation number 9. Easy. So like that you can calculate it. This 18, 19 you may not remember, but still if you remember it's good. Easy. Now fin effectiveness means whether we have to use fin or not. If the effectiveness is very less, better not use the fin. Normally it will happen. You understand? By using a fin, you should get some help. Is it not? At least twice it should be. If fin effectiveness is less than 2, it's better not to use the fin. Okay. Effectiveness shows whether to use the fin or not to use. Once you are okay that we have to use, then we go with fin efficiency. Getting the point? So this is fin performance two ways. One is by fin effectiveness, and another one is fin efficiency, which we have not discussed yet. Now we have discussed only fin effectiveness. We have done with the fin effectiveness. Done. Area of cross section is the same. This area of cross section, why did we take area of cross section is important. See, if I have, this is a heated surface. Here I have to put a fin. What I will do, I will put a fin for that matter. I'll put a fin. If I use the fin, what are the, before using the fin, what was the cross section? Cross section was this. Heat transfer happens because of this fin. By convection, it is going to happen. That is heat transfer without fin. If I had a surface where heat transfer is happening, where the heat transfer is happening? This place. Where air is moving over this. Now there you have placed the fin. So what happens? Heat transfer with the fin. With the fin, total fin. What is heat transfer? Heat transfer without fin. Which is HAC into theta B. AC is the cross section area. Makes sense? Not comfortable. Saying yes is not comfortable. Comfortable, huh? Ilva. Heat transfer ಎಲ್ಲಿಂದ ಆಗುತ್ತೆ ಈಗ ಒಂದು ವೇಳೆ see let us say this mobile is heating a lot. For example, this is my mobile, has a lot of heating which is happening. I want to reduce the heating of this mobile. What I will do, I will stick small rods onto it. Right? Why it is heating? It's heating because the convection heat transfer through the convection is less. So what I do, I will put a, instead of pin fin, I'll put a pen fin. Okay, so I'll add a pen fin here. Okay, so if I had a pen fin here, what's going to happen? From this mobile to this pen, there is conduction which is happening. You understand? Previously, at the same cross section of the pen, what was going on? Convection was going on. Convection because of what? Because of the fan, maybe. Okay, heat is transferring from which area? That area only. Now you put the pen fin. Then what is going to happen? This heat transfer area is more. The heat which is there here is conducted by this pen. Make sense? So what is the use of having this fin is important. What is the heat transfer without fin? First, what is the heat transfer with the fin? And what is the heat transfer without the fin. If heat transfer with a fin, it is not at least twice that of without fin, then why do we use this welding and all this? Why should we use? Don't use. It is more than it is your uh, call, depending on the engineering application you have. Oh, I hold the phone. I have got. Who is this spark? Hello, hello. ಯಾವ್ದ್ರಿಂದ? ಅಯ್ಯೋ ದೇವ, ಇವತ್ತು ಮಾಡೇ ಮಾಡ್ತೇನೆ ಅವರೇ. ಐ ಆಮ್ ಸಾರಿ, ಇವತ್ತು ಮಾಡೇ ಮಾಡ್ತೇನೆ ಆಯ್ತಾ. ಚಲೋ, ಓಕೆ ಶೋರ್. This person, I went to MedPlus. We bought some this one, and he had charged a lot. Okay, in the sense billing, no, he did not bill it properly. He gave excess. We gave excess to him. Okay. Then I went there and I said, "You have billed excess." He said, "Yes." He gave the money, and he said, "Sir, OTP has to come, and some correction has to be done because for his." This one. I said, "Fine, okay." But it was my all the MedPlus is with my father's account, and father does not know what you say when he goes. He does not know if OTP comes. He cannot phone and tell. So I have to go to my home and ask this person. There is a lot of this, and I have to see my father is at home, okay, and then I have to take his mobile, okay, and then a lot of dilly dally is there. Okay. I cannot just like others people. You can call and say, "Tell me the OTP." You cannot do so. He'll say, then my father will say, the phone is not good. My phone is not good. It does not. Sometimes he just calls. His friends are there sleeping in the night. They will call. They will call again back. He said, why did you call in the night? By mistake. He does not know how to operate the phone. That's it. Anyhow, sir. Sorry? And if the call goes, no, he will know that the call goes. What does he do? He'll switch off. Thinking that it is wrong, and even tells confidently that I switched off, I cut killa, I've done cut, I've cut the call. I don't know how did it go. Okay, yeah, tell me. ಹ. ಹೌದು ಮಾಡಿದ್ದೇವಲ್ವಾ, ಅದು ಇದ್ರಲ್ಲಿ ಮಾಡಿದ್ದೇವೆ. Convection through the fin we have considered here, which we have derived today morning. Make sense? This is what we derived today morning, is it not, for a long fin? You. This is for an insulated tip. This was what we calculated. This is two easy ones. Correct? Others are big, big things. Make sense? ಕ್ಲಿಯರಾ? ಹೋಗೋ ಮುಂದೆ. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, ಯಾಕಂದ್ರೆ ಎಷ್ಟೋ ಕ್ವಶನ್ಸ್ ಬಂದಿದೆ ಇದರ ಮೇಲೆ, ಪಿನ್ ಎಫೆಕ್ಟಿವ್ನೆಸ್ ಮತ್ತು ಪಿನ್ ಎಫಿಷಿಯನ್ಸಿ. Now understanding pin efficiency is important for this. Okay. Pin effectiveness you have got. Pin effectiveness is to decide whether to use the pin or not to use the pin. If pin effectiveness is less, don't use the pin. Okay. Next, let us see pin efficiency. Another performance parameter. Yes, please. ನಾನು ಒಂದು ವೇಳೆ ಅದು ಲಾಂಗ್ ಫಿನ್ ಆಗಿದ್ರೆ ಇದು ಬರುತ್ತೆ, ಒಂದು ವೇಳೆ ಇನ್ಸುಲೇಟೆಡ್ ಟಿಪ್ ಆದ್ರೆ ಇದು ಬರುತ್ತೆ, ಬಾಕಿ ಯಾವ್ದಾದ್ರೆ ಇನ್ನೊಂದು ಬರುತ್ತೆ ಅಷ್ಟೇ. ಅರ್ಥ ಆಯ್ತಾ? ಒಂದೊಂದು ಕೇಸಲ್ಲಿ ಒಂದೊಂದು ಡಿಫ್ರೆಂಟ್. ಫಾರ್ ಸರಿಯಾ? ಸರಿ. ಪಿನ್ ಎಫಿಷಿಯನ್ಸಿ ಅಂದ್ರೆ ಏನು? ಪಿನ್ efficiency is given as fin efficiency, theta f is equal to actual heat transfer from the fin divided by maximum heat transfer heat transfer from the fin. If entire fin, which happens, I'll change it, which happens when entire fin surface is at the fin base temperature, at the fin base temperature. What is it? Fin efficiency beta F is equal to Q naught divided by Q max, which is given as a Q fin, I will say Q fin, whatever the Q fin happens, Q fin dot. So this is Q fin dot divided by, or okay, no, I'll write it like this, okay. Q naught. Q naught is sorry, Q from the heat rate, actual fin is fin divided by Q fin divided by H. Area of the fin, area of the fin means convective heat transfer area, or I'll write convective heat transfer area, okay, plus into we have theta B. Make sense? Did not understand? Take some time to understand. Very, very important this is. Shane got the point? See, when will be the maximum heat transfer from the area of the fin will be got? When the temperature of the entire fin is equal to the base temperature. That is the max, which is not theoretically not possible. Agreed? But then if it happens, it's a maximum. So that maximum is in the denominator. In the numerator, it will be in the numerator, it will be the actual heat transfer. Makes sense? Understood? Again, repeat. See, I have this fin which is put here, for example. This is a fin which is put here. Now here you have theta B. Now we know as it comes down, the theta B reduces, right? Temperature reduces. So what happened? The temperature from here reduces. This is the theta tip, right? This is the theta B, correct? This is 0, right? What is theta B? Theta B is T wall minus T infinity. What is theta tip? T tip minus T infinity. Tip T infinity is over here, outside. Makes sense? So maximum heat transfer happens when the whole temperature is at theta B only, which is not practical, I know that. You know, I know. But then what should happen? That is the maximum, ideal. You compare to the ideal. Make sense? All T temperature theta B, there is no decrease at all. Means conductivity should be very high. Conductivity of the material is infinite, only then this will happen. Is it not?
It is applied for the surface, then what temperature it will be?
From here till here, it should be like this. It should not change. Then maximum heat transfer. It will lose energy. Why it will not lose energy?
So it's losing the continuous supply.
Continuous supply is there. That's it.
So more heat transfer.
More heat transfer, maximum heat transfer. Makes sense? This is fin. This okay. So theta not actual, theta fin. Okay. Okay. You can write all the other things, and we can get the things. So just a second. Now all these things I will not do. Okay. So for each cases you can calculate that. Okay. They have calculated for each case. We will not do that. Okay. That's it. Fine. Triangular fin. All those things is not required. Okay. Now let us go with problems. That's enough. Okay. So I do things which are more necessary. Okay. Not just for gate, but afterwards also. But sometimes I have to stop myself. Okay. Heat transfer fins. Where are you fins? A fin. Hello fin. Where are you? Yeah. Let us do this. See here, there is a question here, very super question. This has come in 1992 for 2 marks. Were you born at that time? Right? At your -8 age. Okay. 8 years before death in your previous birth. Okay. So let's see. So here, two rods, two rods, one of length L, one of length L, and the other of length 2L, of length 2L, are made of the same material, same material, and have the same diameter. Write it along with me, students. Same diameter. The two ends, the two ends of the longer rod, of the longer rod, are maintained at 100 degrees centigrade. Okay, 100 degrees centigrade. One end, one end of the shorter rod, one end of the shorter rod, one end of the shorter rod is maintained at 100 degrees centigrade, while the other end is insulated. Is insulated. Both the rods, both the rods are exposed. Both the rods are exposed to the same environment, to the same environment, to the same environment at 40 degrees centigrade. 40 degrees centigrade. The temperature at the insulated end, at the insulated end of the of the shorter rod is measured to be is measured to be 55 degrees centigrade. The temperature at the midpoint of the longer rod the longer rod would be would be A 40 degrees centigrade, B 50 degrees centigrade, C 55 degrees centigrade, and D 100 degrees centigrade. It's a good question. Not very difficult, but you can calculate. So what do we have? Solution. First, let us take a longer rod of 12. One side is 100, another side is 100. Right? We have to calculate the temperature at the midpoint, which we do not know. We do not know that, right? So this side is 100, this side is 100. Okay. Here, if you consider on the other side, we have a shorter rod of L. This side is insulated. This side is insulated. And the temperature at the midpoint, at the insulated end here, is 55 degrees centigrade. And this is exposed to the what is the outside temperature? 40 degrees. So T infinity everywhere. 40 degrees centigrade. I'm sorry. Where is the flame removal mechanism? T infinity is 40 degrees. Right? This is 55 degrees. 100 and 100. This is 55, this is 100. What do we do?
Tendencies to give
Why so?
because profile will be
Why it will be nearly same? I think it's right. Let us see. Let us see. Why the profile is the same?
insulated, so there will be excess temperature which will that is not
Let us see what is the answer. Answer is correct, but let us get in the proper way. Intuitively, you have got the right answer because he thinks that it is insulated over here, okay, and it's 100 degrees centigrade here, 100 degrees centigrade here. So it has to come to 55 degrees centigrade. But let us put the proper way, use the things and tell me. What's the temperature distribution? For this, you need to know the temperature distribution for the insulated rod, and both being kept proper. You have to apply and then get it. There's no other way. There's no other way. Apply the equations, get it. Calculate what is m, which is root of hp by. Do it, do it. It is same thing. But if you guess, it's a guesswork. It's correct guesswork, but it has a basis. What is the thing for the same temperature or end of a fin maintained or given a fin for a given fin tip temperature, given fin tip temperature. What is theta? Theta is given as, if you consider, on this side, so this is what we did. Okay, not convection. This one. This is the. If you multiply here, you can multiply this. You see, you can multiply this here. So what you get? This gets cancelled. Here you have 1 by Tb minus T infinity. You have to use this equation. Use this equation, students. Correct. You get the temperature profile. This equation has to be used. Keep m just like that because m is a material property. Which one? Second one. First one. Both ends are kept at the same temperature. That one. If both ends are kept at the same temperature, then what? Hello. What's happening? Not convinced.
Sir,
Yes,
there
please.
in bracket it's a small l, right? Numerator.
Which one?
Sin h.
Ah, yeah, last one. Yes. That is because I was using Senjal. Okay. And I used L. First I went from Nag to Senjal. So there was a problem. Yeah, that is small L. Correct. Do it fast.
There is no other way.
You have to remember.
That time they
No. They used to guess. This is a guesswork only. They guesswork. What you have guessed, same thing they should have done. But then guesswork is a guess. What you have to do, this is the only. And that intuitive understanding is appreciated. But be familiar with these things. So here I can always say, see here, this is theta at any position. Okay. I can say this as, I can write that equation as theta is equal to theta at the base, okay, theta at the base, which is same, theta b or theta at 1 is the same, okay, into sine h of sin h m of L minus x, or h of mx, we have said, right? Mx minus plus theta at one end and other end. We will put this is end 1, this is end 2. Okay, let us say this is end 1, this is end 2. No, don't have to worry because both are same, right? Into sine of h m into L minus x, right? Divided by sine h m l. This is a theta variation, is it not? Yes or no? Do it, students. Okay, theta is here. Theta 1 is equal to theta 2. What is m? M is square root of hp by ka, right? It's the same. Keep it like that only. Don't change it. Keep it the same. Okay. So what we will have here, theta, we can bring it out, divided into sine h m x minus sine h. This is theta at ends. Theta ends. Theta bases. Two bases are there. Base 1 and base 2. Right? Theta h m into L minus x, small l of course, divided by sine h ml. Fine. This is theta which is there. Theta at zero point 0.5 is what? Right? Theta at zero point 0.5. Theta at x is equal to theta is equal to x is equal to L. What is it? In the longer fin, this is a longer fin, is it not? Here L, or theta is equal to x is equal to longer fin by 2. This is 2L, is it not? This is 2L we have used. So we will use this as 2L here. Let us use instead of L minus x, let us write 2L minus x. Fine. Makes sense. Now what happens? Theta x is equal to L is equal to theta p sine of h m l minus sine h m 2 ml, or m into L 2L minus L, right, divided by sine h ml. Ml is, this is sine h 2 ml, I'm sorry, this L has to be 2 ml, correct? 2L we have taken, 2 ml, we are taking 2 ml, 2L. Makes sense? So sine h 2 ml. So now what you will get here, you will get theta b into sine h ml, you will get sine h ml minus sine h L minus 2L minus L. What is that? 2H minus L is sine H ml, correct? Oh, this is plus. I'm sorry. This is plus. I'm sorry. This is plus, right? Why did I use minus? I shouldn't use minus, right? So this is plus divided by sine H 2 ml, right? Hello, students. Do it fast. Huh? No, no. Using one, we find out its properties. We find out m, and that you apply in the other places. Big one, please. So should we leave this? Saying intuitively, you it is 55. Close, close to us. Yeah, you have to do intuitively in the sense. See here. Yeah, it is length. This is 2L. This is L plus L. and here in between you have here. Okay, this, if it is, this is what we have to calculate. This is equivalent to having 100 here and this being insulated. If they are equivalent, then it is 55 only. That's one of the way, or else we have to do with it. Okay, it's the same. In fact, it is the same. Okay, so we'll, yeah, it is to be. It is type first. Exactly. Then apply back. That's how we have to do realistically, but this intuitively you can do this. Okay. Chalo. Let us stop it here. It's 50.
There, sin HM and all those things, you can convert it into e power x minus e power
That
x.
also can be done. Yes.
So
2 by
the whole term is minus
2 by e square,
so the answer will be 56.
not 55. How did you get 56.2? Do you know m there?
No, we can cancel out. I converted it into e power x. Hx
Okay, let us do that. Okay. So theta b e power ml minus e power minus ml plus e power divided by 2.
2 into that.
Which one?
Whole term. 2 into whole term. The same term.
It's okay. You do it and get the answers to this. Okay, don't worry. So you will get, see here, 2 sine HML divided by sine H 2ml, right? So you will get this as, observe here, theta variation is like this, right? Theta in the middle, right? E power x minus e power minus x divided by 2. Okay. Is it not? Yeah, that's correct. Exactly. N. Yes. Correct. 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 Yes. So it can be done. You have to remember that. That's it. It can be done. First, you have to do the insulated thing. Okay, that is the only. I leave it to you, students. Do it. Okay, don't miss that. I'll do the next one. Here, these are some things which you have to be. Should I give some time? Okay, next. Next question is like this. If he's calculating, let him calculate. Shane, solve. ಆಲಸ್ಯ ಮಾಡಬೇಡ. ನೀವು ಎಷ್ಟು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ತೀರೋ ಅಷ್ಟು ನೀವು ಮೇಲೆ ಬರ್ತೀರಾ, ಇಲ್ಲಾಂದ್ರೆ ಆಗಲ್ಲಪ್ಪ. ನೀವು ಕಷ್ಟಪಡಲೇಬೇಕಾಗ್ತದೆ. I'll do this to you. Oh, shit. Hello, madam. Hello. Good evening, madam. 5 to 7. Okay. Can you make it 4:45 to 6:45? Yeah, because 7 o'clock Velmurugan is there. Or 4:30 to 6:30. Is it possible? Oh, and see, madam, we'll keep at 4:30. If you can come at 4:30, it's fine. If it is 10 minutes more, then don't worry. Okay. So 4:30. Okay. So at what time did we start last time, madam? We started at 7. 7. Same thing we'll do, madam. Okay. Yeah. 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 Sure. Okay. Thank you. ಚಲೋ ಬಂತ ಮಾಡಿ ಬಂತ ಆನ್ಸರ್ ನೀವು ಹಾಗೆ ಮಾಡಿದ್ರೆ ಆಗಲ್ಲಪ್ಪ ಹಾಕ್ಬೇಕು ಸೊ ಹಿಯರ್ ಅಬ್ಸರ್ವ್ theta in the case of this one is theta not insulated tip is theta naught into cos h of m l minus x, right, divided by cos h mlx, right, theta ml, right, theta cos h ml, right. So when x is equal to l by 2, insulated is insulated, x is equal to l, what will happen? This will go as 1. So cos h ml, so you get theta is equal to theta naught, that is theta naught or theta base, into this one will be cos h m into l minus l, which goes to 0. So divided by cos h ml. What is theta? Theta at that place is given as theta at l is equal to l is given as 55 degrees is equal to theta b, sorry, 55 minus 40 is equal to theta b is 100 minus 40, is it not, is equal to, this is 1 by cos h ml. Make sense? So using this we get ml is equal to, if you solve it you get 2.063. This you have to apply back there in the equation where you get theta is equal to theta b into, or theta 1 into sine h ml divided, you get the value of ml that you have to apply, sine h 2 ml. So you will get theta 1 is equal to 100 minus 40 into sine h ml, sine h of 2.063 divided by sine h of 2.063 into 2. Top one, 2. Yes. We missed that. Yes. That's, so you have to remember these things. Okay. It's not much difficult, but that is what you get the edges. It's not when you remember. Yes. So it's always better you remember. If you cannot remember, don't worry. That's what I say. But if you can remember, please remember. Should not panic at any point. get at least 50 marks are there which is scoreable. Now, if your aim is to score more than 80, then you have to work. It's not easy. When you go towards more and more marks, it becomes much and much harder. The efforts you put till 50 marks, the same efforts you have to put to go to the next to 25. The same efforts next to 10. The same efforts next 5. Huh? So what will happen here? Effort I'm talking. I'm talking about efforts. 90 marks is enough, is it not? For me also it's enough. It's the same. Theta 1 is here, theta 2 is here, which is theta base. Both sides is kept at 100 degrees centigrade. Read the question again. Theta 1 is actually, in case of saying that theta 1 is at the 1, theta 2 is at 2. This can be considered as a base, this can be considered as length. Yeah, here if you see the formula, observe. You multiply by TB minus T infinity. So what you get, TB and T infinity cancels here. So what is TL minus T infinity? And here you will get TB minus T infinity. So one is at the base, the other one is at the other end. Good enough? Remember these things, okay? Oh no, I lost my time in circles. Done.
This was last question other than specified temperature.
This was not the last question.
Did they give after 20?
Let us see. Let us see as we go. We will solve all the problems. They may give, they may give. It is there in the syllabus, they may give. Yes. So theta you get it as here. This is what theta is equal to theta at the center of the rod, right? So here you get this theta at the center of the rod is equal to this, which is theta center minus theta infinity. Or sorry, T center minus T infinity. That is theta. We have to see. Not perfect. Put pen on paper. Laziness ಮಾಡಬೇಡಿ ಬರೀ ಕರೆಕ್ಟ್ ಅಲ್ಲ ನಾನು ಲೇಸಿನೆಸ್ ಮಾಡ್ತೀನಿ ನೀವು ಮಾಡಬೇಕು ಜಿಂಕೆ ಜಿಂಕೆ ಆಗಿ ಹೋಗ್ಬೇಕು ಮೈಂಡ್ ಕರೆಕ್ಟಾ yeah see here it is 2L but we are considering at the middle when L is equal to see here it is X is equal to L whereas capital L is 2L see fine ಬಂತಾ ಖುಷಿ ಆಯ್ತಾ ये खुशी मैं सभी भारत के हर एक नागरिक को देना चाहता हूँ temperature same ಇರ್ಬೇಕು, diameter same ಇರ್ಬೇಕು. ಇದು ಟೆಂಪರೇಚರ್ ಸೇಮ್ ಇರಬೇಕು. ಆಯ್ತಾ ಸರ್?
So if the base temperature is same and everything else is same, it has to follow the same thing.
Exactly. That's right.
So that's where we can assume the temperature.
Yes, yes, but it's a guess. It's a guess. Because here you are you are in the post truth, right? After you know the answer, you are going to the saying how can we get the answer. But there you do not know that. That can be so easy. After coming back from the match, everybody will say, hey, ಅದು ಇಲ್ಲಿ ಬಂದಿದ್ದು ಈಗ ಹೊಡಿಬೋದು ಹಾಗೆ ಹೊಡಿಬೋದು ಅಂತ ಹೇಳ್ತೀರಾ? ಆ ಮ್ಯಾಚ್ ಅಲ್ಲಿ ಹೊಡಿ ಗೊತ್ತು ಎಷ್ಟು ಕಷ್ಟ ಅಂತ. You understand? So it's about match practice. Here everything is, see here your net practice you're doing, and you know how the ball is coming, and that also you don't hit at the first end. After a lot of practice you hit it, but there you do not know, new ball comes, you do not know what to expect. Correct? So don't think gate is that easy, but it is easy to clear. Let me tell you, it's very difficult to score above 60 or 70. The people who have scored above 60 are great people, for sure. Okay? Yes. What happened? Huh? I also scored 60, but it was out of 150. 150 marks. I scored around 65 or 70, that range. 388, All India.
After it was
Huh?
less.
There were around 19,000 people.
No, but 300 rank was like less than 50% of it.
Yeah, yeah. Maximum was 120 or something like that. It never crossed 130, was very rarely it used to cross. Because that time, see, today you have aptitude and English, then you are feeling 3 hours is difficult. The level of questions were no less. Okay, but then what used to happen, in 3 hours we have to write 150 marks. That was difficult.
I think in this 1994 was they did the descriptive.
They had descriptive also. That was still difficult. And we did not have NAT. Everything was MCQs. No NAT, no MSQs. We used to get negative marks in loads, in bulk, and no aptitude and English to increase your marks. Full was starting to end is districts only. So out of that, it's good only for me. I cleared. I got into IIT. Happy. Who is going to dissect which is easy, which is? So don't know. No, you are not going to remember that also. Okay, now you get into IIT, then you calculate your papers pay package. That's it. Be happy. Okay, chalo. Now struggle for that. Okay. Now you can imagine about your pay package only. Okay, and struggle now. Okay. Chalo. Now, uh, okay. The other question is that this is in 2010, 2 marks. 2010, 2 marks. Students come here. A fin, write down, write down. A fin has 5 millimeter diameter and 100 length. Length. The thermal conductivity of thin material is 400 watt per meter per Kelvin. Kelvin. This is Kelvin. Okay. Per Kelvin. One end of the fin one end of the fin. Mainly, sir, Jaitwa, one end of the fin. One end of the fin is maintained is maintained at 130 degrees centigrade, and its remaining surface and its remaining surface is exposed is exposed to ambient air at 30 degrees. If the convective heat transfer coefficient, the convective heat transfer coefficient is 40 watt per meter square Kelvin, the heat loss in watts from the fin is A 0.08, B 5, C 7, D 7.8, which is a lucky number you can. People guess even in this. See, there are people who write it from starting to the end. They keep on writing. Ask 100%. Everything we have attempted. Everything I have attempted. There are people who say that. I hate that, hate that. You should never do. ಇಲ್ಲಿ ತಾಗಬೇಕು ಅಲ್ಲಿ ತಾಗಿತ್ತು. Meter square Kelvin. How? Heat transfer coefficient. ಹೌದು ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಮತ್ತು ಕೆಲ್ವಿನ್ ಇನ್ವರ್ಸ್. ವ್ಯಾಟ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಕೆಲ್ವಿನ್ ಇನ್ವರ್ಸ್. ಅದು ಆಕ್ಚುಲಿ ಹೀಗೆ ಬರ್ತಿತ್ತು, ಮೀಟರ್ -2 ಕೆಲ್ವಿನ್ ಮೈನಸ್. ತುಂಬಾ ಸುಲಭ ಇದೆ, ಮಾಡಿಬೇಕು. ಏನ್ ಮಾಡಿದ್ರಿ, ಏನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರಿ? ಲಾಂಗ್ ಪಿನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರಾ? ಸರಿಯಾಗಿ ಲಾಂಗ್ ಪಿನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಯಾಕಂದ್ರೆ 5 mm ಡಯಾಮೀಟರ್ 100 mm ಲೆಂತ್ ಲಾಂಗ್ ಪಿನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. You write this HPKA TB minus T. That's what the answer. बनता 7 बनता, lucky number 7. हाँ, ಸರಿ, ಎಲ್ರಿಗೂ ಬಂತ ಸರ್? ಕರೆಕ್ಟ್. ನಮ್ಮ ವೇಲ್ಮೂರ್ಗ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ ನೋಡುವ, ಹೇಳಲಿಕ್ಕೆ ಮರ್ತು ಹೋದ. ಓ, where is my mobile? Shit, he put it. He put it at 6:15. I did not see it. Come on. He gave a missed call also. Shit. I'll tell you. Okay, done. Got the answer? Yes. Will Murugan had put it for me that time only. He had put a message. 7 o'clock he had a class, but he had some training. He had some. Sorry, Aita. Next question. I hope your online students got the answer, right? Next. Which one of the following fin configuration? This has come in 2012 for 1 month. Which one of which one of the following configurations has the highest fin effectiveness? A. Thin, closely spaced fins. B. thin, widely spaced fins. C, not thin, thin, then thick, widely spaced fins. D, thick, closely spaced fins. What's the answer, students? Big one. Go ahead. Effectiveness on the end. With fin, without fin. Effectiveness is with the fin and without fin. What is the question? So which is better? Thin, closely spaced fins. You have a heated surface. This is heated surface. You have thin fins, closely spaced. First case A. B case is thin, widely spaced. Right? C. Thick, widely spaced. Thick. So everything when you draw it, everything will become evident. Thick, closely spaced. Which one?
A, sir.
A, of course, yes. A thin, closely spaced. Yes, you have to see the AC. Previously, in the old one, I used to see show the AC this one, condenser close. Did not thin, closely spaced. Okay, but it should not touch each other, of course. Space. Convection, they should be space. Fine, done. ಅರ್ಥ ಆಯ್ತಾ? ಹಾ ಥಿಕ್ ಯಾಕೆ ಆಗುದಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಥಿಕ್ ಆದ ಕೂಡಲೇ ಏರಿಯಾ ಕಮ್ಮಿ ಆಯ್ತಲ್ಲ. ಕನ್ವೆಕ್ಷನ್ಗೆ ಏರಿಯಾ ಎಷ್ಟು ಕಮ್ಮಿ ಆಯ್ತಾ ಇಲ್ವಾ? Fins, what is the main purpose of fins? To increase the area of convection. If you use this, what's going to happen? Area for convection is less compared to this lot of area of convection. If I use it, okay, let us not use this. Let us use a fin like this. Right? Area of convection is, if you cut it here, you will have more area of convection, is it? So, next.
Closely or widely spaced.
It's general. General. When you thin, closely spaced, and thin, widely spaced, which is better? Thin, closely spaced, is it not? Don't worry about specifics. Okay. Next question. uh, okay. This is question in 2017 for 1 mark. Let us see this. The heat loss. The heat loss from a fin. From a fin is 6 watts. The effectiveness. The effectiveness and efficiency. Efficiency of the fin of the fin are 3 and 0.75 respectively. respectively. The heat loss, the heat loss in watts from the fin, from the fin, keeping the entire fin at base temperature, at base temperature is dash. One mark. This has come in set 1, set 2. I'm sorry. If you know the basic definition, say what's the answer? Huh? 8. 8 fans. Correct answer. One mark easily ಬರುತ್ತೆ ಅಲ್ವಾ? So fins today is enough. Tomorrow morning I will start with unsteady heat conduction. Huh? ಇನ್ನೊಂದು question fins ಅಲ್ಲಿ. Okay. Write down. This has come in 2021 for 1 mark. And ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಎಲ್ಲಿಗೆ ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿದೆ ಇದ್ದದ್ದು? ಅರ್ಥ ಆಯ್ತಾ? ಅರ್ಥ ಆಯ್ತಾ? ಅರ್ಥ ಆಯ್ತಾ? And infinitely online students, long fin attached to an isothermal hot surface transfers heat at a steady state, at a steady rate, at a steady rate of q1 dot to the ambient air, if the thermal conductivity if the thermal conductivity of the fin material if the thermal conductivity of the fin material is doubled is doubled while keeping everything else constant. Uh, Everything else constant. The rate of rate of steady rate heat transfer. Steady rate heat transfer. Steady rate heat transfer from the fin from the fin becomes Q2 dot Q2 dot. The ratio Q2 dot divided by Q1 dot is A to B 1 by 2 B 1 by root 2 C, or what am C. Forgotten ABCD students. To go to school again. Okay. Answer. This should be like root. Should be a bit louder. I can be low on voice. You should be louder. When you have the answer, you should say root. ಗೊತ್ತಾಯ್ತಾ ಹೇಗಂತ? What is Q for the long fin? Square root of HAKT. That's it. Into delta T, of course, or into theta, theta at the base. Everything else is constant. Conductivity simply equals. Easy. So I think we'll stop the class today. Okay. Few minutes. Yeah, 40, 20 minutes. Okay. So here all the things about fins are over, students. Now what is there now more is all the questions on the fins is over. No, one more question is there. One more question. We will do that one more. 2010. I've done. 2010 mark 2 marks question I've done. Yes, I've done. I'm sorry. Wait. Uh, then wonderful. Till now on fins. I expected more questions for it, but I think it's very less. Okay, 2022 we will see once. So we have done all the questions which has come in gate pin fins. IITK gate. From tomorrow we are going with wait, fins. Heat. Here are. Okay. Yeah, this is a good question. No, not this. This is can be done. Good. Question number 45. There was one student who told us, sir, this time the in the GATE exam, no, GATE 2022, no, it was long. Reading the question only was a great deal. Answering is leave it. Is it not? That's what happened. Huh? Some students said that. Huh? Set one, I suppose. Set one. You had set one? So, no, no, no. I don't know whether it's thin or not. It looks similar. Yeah, I think you can solve it. We'll see. I don't know. I thought it you can solve it. I did not read the question fully. Consider the rod of uniform thermal conductivity whose one end x is equal to 0 is insulated. This is insulated. And x is equal to L is exposed. Other end only is exposed to the only the other end is exposed to T infinity. Okay. Yes, surface is insulated. Okay. So is insulated, uh, whose one end is insulated, on the other end is exposed to flow of air at temperature T infinity with convective heat transfer H. The cylindrical surface of the rod is insulated. Oh, wow, 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 wow. Ware, wow, ware. Now, the cylindrical surface is insulated so that the heat transfer is strictly across the surface. Okay. The rate of internal heat generation inside the volume of the rod is given as Q dot is equal to cos of 2 pi x by n. It's an easy question, but you should be in that calm mind. Okay, the steady state temperature at the mid location of the rod is given as Ta. Okay. What will be the temperature at the same location if the convective heat transfer coefficient increases to 2h? What? Easy? Why? How come same? Heat transfer is happening from here, pa. Heat transfer is happening. H is increased by twice. Insulated here, not over here. See, other end is exposed to flow of air at temperature T infinity. Correct? Not easy, not easy, not very easy. But it's solvable, but it's solvable. It is solvable. Put your pen on paper, you will get it. Huh? 2022. See, it is not about question being tough as such. Question being a bit moderate in a gate exam will seem tough. Easy question will seem moderately tough. ಬಂತಾ ಆನ್ಸರ್? ಮಾಡಿ ಮಾಡಿ ಮಾಡಿ. We'll see. How did you get that first of all? Then? Why it will be plus? How it can be plus? No, how it can be plus? This question is if it is TA, when heat transfer is increased. Okay. See, if the convective heat transfer coefficient increases to 2H, how it can increase? It should only reduce, is it not? Why? No, heat generation is the same. Cos of 2 pi x by L. Heat generation does not have anything with respect to temperature or H. Then if you apply your mind, in my opinion, I think you should give this as the option. Why? Because when you increase the heat transfer coefficient T infinity, when you increase to H, it is said whose one end is insulated. Wait a minute. The rate of internal heat generation in the rod is given as this. The steady state temperature. What is the temperature at the same location? If we, okay, there is a possibility that it can increase, is it not? Why it can increase? See, let us understand. Okay, see here. In my opinion, if heat is generated, this is to have more temperature, this has to have less temperature. Convection heat transfer is happening through this. Correct. Now, if I increase HA, few heat transfer due to convection, I don't know why you are not understanding the simple one. HA delta T. If H is increased, then what is going to happen? More heat transfer is going to happen, is it not? So when more heat transfer is happening, what about the temperature at any location? It has to reduce, is it not? Will it increase or reduce? It reduces, is it not? That is my point. So here you have seen increasing. Here you have seen increase. Here you see same. What it should be? It should be this, is it not? Heat transfer when you have what difference should be less? Whatever be the case, it will reduce. No, TA will increase or reduce. There is a heat generation happening. Heat transfer coefficient, which is taking the heat. Okay, convection heat transfer. Whatever heat is generated here is taken away by this air. Now, when the heat transfer H is given, temperature is TA. If which gives QC is equal to HA delta T. If this is made 2 times HA delta T, don't you think TA reduces? Yes or no? Agreed. So what should happen here? It should be TA minus TA into Q dot L by 4 pi H plus Q dot L divided by 4 pi H into T infinity. Right? TA is lesser. This is TA is more, T infinity is less. So my answer, although it is a guesswork, based on the conceptual knowledge, I would answer D. We will see whether I will get a wrong answer or the right answer. Agreed? You don't think so? Which is the answer according? You did not understand. Okay, let us see. See, this is a heat is generated here. Inside everywhere heat is generated. Fine. So now what is Q dot? 2 pi x by L. No, 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 no. Answer is T. I'll tell you why. TA. See, why? I'm wrong. Mine is wrong answer. Why? Because what is the Q? Oh, no. Why do you think it's B? No.
Something you have done.
Okay.
Can you just explain what you did?
Let us try. Q dot is equal to cos 2 pi x by L. So when what is the Q dot? Maximum Q dot at x is equal to L. What is Q? Cos of 2 pi. Cos of 2 pi is 1. Is it not? Q dot will be 1. Okay. Same it. L is equal to 0. Correct. So how is the Q generation here? Q generation is maximum here. Then it goes 2 pi x by L. So it goes as 2 pi. Is it not? Yes. 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 So it will go like this. It will go like this. It will go this way. Is it not?
This actual x will be L by 2, so
Yes. L by 2.
so it will be pi
Yes.
minus.
Yes. Minus. Yes. This is the heat generation which is happening. Sinusoidal heat generation. Fine. Okay. Okay. Come back. Come back. Okay. So now let me explain my thing to you. Okay. So heat is generated everywhere. This is minus means what? This is minus means heat generated is minus means it's a heat sink. It's a heat sink. So whatever is heat generated is removed here. Heat generated is removed here. So whatever heat generated is removed in the between. Then here whether you increase or reduce, it does not matter. It is TA. Let us see. So question number 45. The answer it can never be increased. It's either C or D. It cannot be two times. Now you do not understand why it cannot be two times, is it not? Why is this wrong answer? Why is this wrong answer? I will tell you. See, heat being generated means what? There is something which is poured into it. Something is growing. Okay, and this H being there means what? Something is being removed. Make sense? So now, when the rate of removal is increased, what should happen? The content should reduce, is it not? For example, there is one farm in which there is continuous, say, which farm we will have? Papaya farm. Okay, we will have papaya farm, a big one, a 10-acre farm, papaya farm we have, and there is one person to pluck the papayas. From morning till evening, he does that. Okay. Now what happens? Number of rotten papayas, okay, will be a particular one, or number of ripe papayas in the this one will be one number. Now you employ two people, then number of ripe papaya should reduce, right? Should not increase, right? Are you getting that papaya? This one. See, the one which is removed, which is generated, is the same. Now H being increased means what? The rate of removal is increased. When the rate of removal is increased, What should happen? What is the temperature there? It should be less, is it not? It cannot increase. Basic thinking we have to put. So A and B is gone at once. Which one? Papaya I should explain. Ah, see, don't. Okay, let us see. Okay. See, the thing. Okay, see here, there is generation which is happening. Okay, for example, you have a lot of papayas are growing here, and there is one person H which is going inside and removing the papayas, and it's growing at a particular rate. It is being removed at a particular rate. So depending on the growing rate and removing rate, the steady state of number of papayas will be one thing. The steady state will be TA, right? Now, if I have instead of H, if I have two H, two people are there, then what happens? Number of papayas should reduce, is it not? So instead of papaya, put temperature. Instead of removal, H is H only. Generation rate is the same. More heat is removed. Heat generated means what? Heat is being generated. Q dot is heat is coming out there. Heat is coming out due to some reasons. H means what? H means what? It is being removed. When H is increased means what? Removal rate is increased twice. So temperature should drop. So it is not about doing a lot of things, it's about thinking. So the person who writes D has put his effort that it will reduce. But he has not seen Q dot being cos 2 pi x by L. He should plot this. Then he will understand that this area is same as this area is the same as this area. Minus means heat is removed. So heat is added is equal to heat removed. Heat removed is equal to heat added. That is a cosine curve inside the rod. Decreases, not decreases, it is removed because cos h2 pi l. So heat is generated on one end. Here it is eaten up or removed. Here it is removed. Here it is added. So what happens? Net generation in the heat is zero. You can do this also by integration of q dot into dx. Integration of q dot into dx, 0 to L, q dot into dx. You can do that. You will see that net heat generated 0 to L cos of 2 pi x by L is actually going to 0. So when there is no heat generated at all, whether you have H, 2H, 10H, 20H, it's still
Every point that temperature will be the same, regardless of your
the temperature will not be the same. We are talking about midpoint here.
midpoint of the
Yeah,
it
it changes. Other places it changes. But that is the idea. That's why 2022 was difficult. It's about basic concept to be seen. If a person rushes, gone. If a person panics, gone. He has to keep his equanimity. And then he can answer. Where is memory here? There's no memory here. It's more of application. Correct. Basic thinking. Sure. Thank you.